projectile motion. And not necessarily too much new to say here. We've already discussed the kinematic equations and how they came about. There's usually a fifth one that I've written here, but the truth is that fifth one just doesn't get used a lot, and we can solve everything we need to solve from these four. So let's make the equations a little less. We really don't need that fifth one, which is why it's not commonly stated. So I'm just going to ignore that. Let's say we just have these four. These four are good enough for everything we need to do. And these equations are only for the x direction. So the problems we did with the either moving left or right. Our past problems were going up or down. And the truth is that we have a set of equations for each dimension. So here's an x direction, left and right. Here's y, which is up and down. And in 3 dimensions would also be forward and backward. But we won't have any 3-dimensional stuff, so there's not going to be another set of equations. Don't have to worry. But we do have to deal with 2 dimensions now in projectile motion. And something that, when things are a little bit more hardcore, we do have to pay attention to our indices here. So for instance, this is only in the y direction, so the velocity in the y direction, final and initial. But I did separate this with a y for up and down and x for left and right. But these will simplify for us. So that's why I didn't really spend much time on these superscripts here. And let me show you how this will simplify. Is that we're still going to be only dealing with free fall, which means our only acceleration will be due to gravity at minus 9.8. And these equations will only apply to what's in the y direction, because gravity only works in the y direction. It doesn't push things left and right. So we only have gravity for our acceleration. That's it for our projectile motion. And then what that means is, in the x direction, there's actually 0 acceleration, because we're only dealing with gravity in our projectile motion. So there's no friction, there's no air resistance, there's no rocket on our projectile. We just throw it in the air or drop it, and it's affected by gravity. There's no acceleration in the x direction. And then that causes these equations then to greatly simplify if a is 0. So for instance, in this very first equation here, if we have a equals 0, well then that equation will simplify to just the final velocity equals the initial. In other words, there was no change in velocity. If we put a equals 0 here, this equation reduces then to just x equals vt. And if we put 0 in here for a, we likewise will get that the velocity doesn't change. And for this last one, if these velocities are the same because there's no acceleration, then we have 2v. And then that 2 is canceled out by the half. And so we again get the equation that x equals vt. And it turns out that this is the only equation then that we have in the x direction. So when dealing with projectile motion, we will have our 4 equations in the y direction, where acceleration is due to gravity at minus 9.8. But in the horizontal direction, we will only have this one equation, that x equals velocity times time. And of course, you're going to want to see these worked out. So check out the practice problems where I will work these through. But that's really all I have to say as our lecture here. There's really no new equations or nothing new to say, except that we're applying these equations in 2 dimensions. And to greatly simplify things, there's no acceleration in the x direction, which means we only have this one equation. So altogether, for projectile motion, we will be dealing with these 5 equations for all of projectile motion. So check out the practice to see some help with that.